Assalamualaikum and hi everyone. Today, I am Dr. Muhammad Ariff Ahmad Nazri, want to share with you about our next topic of uniform flow in open channel. Before that, we look a little what have been shared with you in the first topic. The first topic discussed with respect to the flow in open channels. I believe you already know and be able to define and explain on types and states of flow, how to identify types of open channels, and define open channels geometries such as rectangular, triangular, trapezoidal, circle, and etc. I hope you also already understand on how to determine depth of flow, normal depth, flow or discharge, mean velocity, wet perimeter, hydraulic radius, and hydraulic depth. It is a little summary of what have been shared with you previously. Therefore, let us continue our second topic of uniform flow in open channel. Before that, the topic is divided into several subtopics. First, velocity distribution. Second one, Chazai and Manning equation. Derivation of Chazai equation, Chazai resistance factor, conveyance, section factor, best hydraulic section, and channels of compound section. So, open channels basically has been divided into two. First is classification based on time, and the second one classification based on space. Classification based on time, consists of steady flow and unsteady flow. Meanwhile, classification based on space consists of uniform flow and non-uniform flow. Uniform flow is considered to be steady only, since unsteady uniform flow practically does not exist. Steady uniform flow is rare in natural stream, only happens in prismatic channels. We adopt or assume uniform flow for most flow computations because uniform flow calculation is simple, practical, and provide satisfactory solution. Velocity distribution. It depends on the geometry of the channels and wet boundary roughness. Chazai and Manning equation. Two most common equations used in the uniform flow computations. First is Chazai formula, then the second one is Manning formula. Difference between Chazai and Manning formula while determining the roughness are surface roughness, vegetation, channel irregularity, channel alignment, silting, and scarring, obstruction, size and shape of channel, stage and discharge, seasonal change, and suspended material and bed load. The following two equations can be used to determine Chazai coefficient. First is Ganglet-Carter, and the second one is Bazin. In Ganglet-Carter, the variable n is known as Carter coefficient. Meanwhile, for Bazin, m is a Bazin coefficient. Conveyance. Conveyance K of a channel section is a measure of the carrying capacity of the channel section per unit longitudinal slope. It is directly proportional to discharge Q. Section factor. Section factor AR power of 2/3 is normally used to compute the normal depth Y0 when the discharge Q, bottom slope S0, and Manning roughness coefficient N are provided. Computation of Y0 could be through either direct try and error computation based on graph or through provided design chart. Best hydraulic section. So by referring to the channel conveyance K, a non-erodible channel should be designed for the best hydraulic efficiency. Best hydraulic section gives minimum area for a given discharge. For a constant flow area A, the conveyance increase with increase in hydraulic radius R or decrease in the wet perimeter P. Simply, Qmax, Rmax, and Pmin give best hydraulic section. Channel of compound section. compound section channels that are composed of several distinct subsections with each subsection difference in roughness from others. So many equation is applied separately to each subsection to determine the mean velocity. So for the learning outcome, at the end of the chapter, so students should be able to understand the concept of uniform flow, calculate normal flow in variable channel, section using Chazay and Manning equation, determine the best hydraulic or effective section of open channel. So thank you for your time.